Greetings everyone. So this is a continuation in my polynomial series. This one is multiplying polynomials and doing FOIL. Enjoy. So last time we did adding and subtracting polynomials and we talked about what a polynomial is. Today we're going to multiply polynomials. So let's try these ones. Just going to start off with 4 here. First one, we're going to find these. So when we're multiplying, what are we doing? We are finding the product. Okay, if we're adding, we're finding the sum. If we're subtracting, we're finding the difference. Here, we're finding the product. So we're multiplying two polynomials here. Can you see the two polynomials? Where are they? We've got one polynomial here. This is a monomial. And the second polynomial is this big beast here. Okay, it's got like 4 terms. We don't actually have a name for that, do we? Got monomial, binomial, trinomial. We didn't have one for 4 terms. Right, but how do we do this? We're just going to use our distributive property. We already did that, I think, when we had just 2 terms here. But when we've got more than 2 terms, we just keep going. We're going to use the distributive property. So we're going to think, okay, 3x squared times 2x cubed. You just do the number and the algebraic part separately. So do 3 times 2. X cubed times x squared times x cubed. What's that? Here we've got to use that rule we got. So if we've got a to the m times a to the n, that becomes a to the m plus n. We add the exponents. So if I've got x squared times x cubed, it's going to become x to the power of 5. Next one, we do 3x squared times minus 1x squared. That's going to be minus 3 times minus 1 is minus 3. X squared times x squared is x to the 4. Next one, 3x squared times 4x. So 3 times 4 is 12. X squared times x is x cubed. And 3x squared times minus 3. So 3 times minus 3 is minus 9. X squared times x to the 0 is just x squared. Okay, so for question A here, this is our answer. We can't go any further. All right, when the exponents are the same, we have like terms, but here all the exponents are different. Okay, we have unlike terms. Looking at that, the exponents are going down. That's kind of like our standard form. The degree of this would be degree 5, wouldn't it? Okay, just to review that stuff. And the leading coefficient would be 6. B, this is the fun part. This is where it starts. Here we have a binomial times a binomial. This is an important part of the lesson. When we have a binomial times a binomial, we're going to do something called FOIL. All right? FOIL. What the heck is FOIL? Well, there's a little strategy we use. When we've got a binomial times a binomial, so can you see the 2 binomials here? 2 terms, 2 terms. Nothing in the middle, which means they're multiplied. This is our binomial times a binomial. We do something called FOIL, F-O-I-L. F means first. We multiply the 2 first terms together. So I've got like x times 2x. These are the 2 first terms. X times 2x is 2x squared. The O stands for outer. We multiply the 2 outside ones first. So x times minus 1 is minus 1x. I stands for, can you guess? The inner or the inside. We multiply the 2 inside terms. So plus 4 times 2x is plus 8x. And L is the last one. Okay, we multiply the 2 last ones together. So what's plus 4 times minus 1? It is minus 4. So that is FOIL. Okay, basically every term in the left side gets multiplied to every term in the right side. As long as you've got all those covered, you're going to get it right. And then can we collect any like terms here? Yes, we've got x to the 1, x to the 1. We can collect the 2 middle ones. So the final answer, 2x cubed, that, oh no, I'm doing 2x squared, that just copies down. Minus 1x plus 8x is plus 7x. And then the minus 4 just copies down. All right, so that is our answer. Very common when we've got a binomial times a binomial, we end up with a trinomial answer. C, FOIL again. What I want you to do is you try this one. You do FOIL on this, okay? And tell me what the answer is. It's going to be equals, doing FOIL, F-O-I-L. Okay, and the answer is going to look something like this. Something a squared, 8 plus something a minus something. what is it? Okay, after you've done FOIL and you've collected the like terms, what is the final answer? Put your answer in the comments, okay? And you can have a little bit of an argument about that if you disagree. D, right? This again is FOIL, but it's like FOIL on steroids. This one's really hard. So can you see the two polynomials? Here we have a trinomial times a binomial. There's the multiplication symbol. So we've got a trinomial times a binomial. Again, all we've got to do is multiply everything in one side to everything in the other side. There's more than one way to do this, but we'll always end up with the same answer at the bottom. So let's do it. I'm going to multiply 2y squared into both of these things. So 2y squared times 3y is going to be 6y cubed. Okay, can you see that? 2 times 3 is 6. Y squared times y is y cubed. And then 2y squared times minus 1 is minus 2y squared. Okay, so that's done. Now I'm going to do minus 1y. Minus y times that is going to be minus 3y squared. Okay, so minus 1 times 3 minus 3. And then minus 1, minus y times minus 1 is going to be plus 1y. Okay, and that's done. And now the minus 2. Minus 2 times 3y is minus 6y. Minus 2 times minus 1 is plus 2. Okay, so we end up with 6 terms. 1, 2, 3, 4, 5, 6 after doing that FOIL on steroids. Now let's collect the like terms. 6y cubed. What about our squared terms? So we've got minus 2y squared minus 3y squared. That gives minus 5y squared. And what about the y terms? We've got plus 1y minus 6y. Collecting like terms there leaves us with minus 5y. And at the end there we've got something called a constant term. Plus 2, that just copies down. Alright, so example 2, we're going to do a little bit of geometry here. A little bit of shapes and area. So looking here, we've got a really large rectangle, okay, shaded area here, and there's a hole cut out of it. Now if you can see that, I hope so. The length is x plus 6, and the height is 5x, 5 times x. And the hole has dimensions 3x by 4x. So we don't know what x is. Everything's in feet, by the way, so whenever you've got actual values for anything, it's going to be feet. Write a polynomial that represents the shaded area. So the area, how am I going to find the area of this? I'm just going to find the total outside area, and I'm going to subtract the area of the hole. Okay, makes sense? Let's do that. So the whole outer part is going to be 5x times x plus 6. And then I'm going to subtract the whole area. Okay, so it's 3x by 4x. 3x times 4x. Do you agree? Is that right? Something's wrong with this? Hopefully you figured that out. We're going to do 5x times all this stuff. So it's 5x times all this, which means we're going to put brackets there. Okay, and you're going to imagine that there's a multiplication symbol there. So we're looking for a single polynomial. Is that written as a single polynomial? No, we've got one polynomial times another polynomial minus, and this is going to be a polynomial in itself. We just want one single polynomial. So we're just going to get rid of the brackets and collect the like terms. Distributive property, 5x times x is 5x squared. 5x times 6 is 30x. And what's this? 3 times 4 is 12. X times x is x squared. Are we done? Collect the like terms. Oh, we've got 5x squared minus 12x squared. Let's subtract those. 5 minus 12 is minus 7x squared plus 30x. That is a single polynomial representing this shaded area. Alright? This is a function, isn't it? Right? We've got an input x and we've got an output area. This is actually a function. And now what we're going to do is move along. What if we know that x equals 2? Well, let's put that in. We're just going to substitute x equals 2 into this expression. Minus 7 times x squared plus 30x. And now this is a BEDMAS problem, a PEMDAS problem. Order of operations, what do you do first? Exponents, minus 7 times 4. Now we have multiplication and addition. What do we do first? We do the multiplications first. Minus 28, 60. Alright, minus 28 plus 60, or 60 minus 28. Remember, commutative property, you can switch the order. 32, and everything is in feet, so it's 32 square feet. Don't forget to get the units correct, all right?